Okay, and we're on. All right, today we've got with us Dr. Nadya Peek. Thank you so much for being here. I'm really excited for this.
You were a robot briefly. Do you want me
Oh,
to introduce myself?
dang. Sure, yeah. I guess we'll fix that in editing, or maybe leave it in because it's funny.
Well, hi everyone. I'm Nadya Peek. I'm an assistant professor at the University of Washington in the Department of Human-Centered Design and Engineering. I'm also affiliate faculty in CS and ME. I run a lab called Machine Agency, where we're focused on the precision of machines and the creativity of individuals.
Awesome. So I think maybe we should start with the burning question on everybody's mind, which is, you're in a band?
I am in a band.
Yeah,
That's the burning question.
it is. That's the first thing I saw when I went to the website. You're in a band called Construction that I should totally listen to.
That's right. Well, that's true. I'm in a band called Construction. My bandmate is Marco Attisari, who is a Finnish bassist, and I make up for my lack of talents of any particular instrument in way compensating with quantity by playing lots of them. We
Awesome.
have canceled all of our shows for summer 2020 for reasons that I think everyone will understand.
Hmm.
But we are releasing our second EP. We're great. Thanks for asking. This fall, both will be it will
Cool.
be released on vinyl and on all
That's
streaming
awesome.
services at the same time. You can get our first EP set also on any streaming service, and also you can get the vinyl at the moment only at a record store in Helsinki, but soon also at record stores in the US.
Nice. Pretty well established. So, I mean, I think that actually is kind of a relevant question, right? So, you're a bit more of an artistic sort of engineer compared to most of the engineering community. Do you think that's kind of informed your work in a certain way or affected your work and success?
I don't really know what you mean with artistic engineer. I think of my work as engineering work, but very much in service of
Hmm.
tasks that I think are very important. I think it's important for engineering to be a solid infrastructure that everyone can use for different kinds of tasks, including tasks that are diverse and maybe not what is currently considered the um, status quo of engineering.
Hmm. Yeah.
And I think that maybe like being a creative person also influences just how I work in general. But I
Hmm.
don't know, like I feel like sometimes it's a bit difficult to characterize some engineering work as creative and under other engineering work as not creative. I think of it
Hmm.
all as creative, different kinds of creative
Right.
problem solving, identifying problems. Um, for me, like music more specifically gives me a way to think about things with immediacy. A lot of electromechanical systems that I design
Hmm.
take a long time, like from when you first start thinking about them to when you can actually test them. And music is sort of the opposite there, where as soon as I play something, it makes noise. You know,
Hmm. Yeah.
it's not a delayed feedback loop. And I find playing music allows me to like work in immediacy, which
Hmm.
is not always the case in engineering, and I sometimes find frustrating. But I do, and I think that that perspective also influences what I think engineering could be like
Yeah.
rather than saying like, oh, we're going to have to do a year's worth of work before we can ever use anything.
Hmm.
To think like, what does it look like to improvise? What does it
Yeah.
look like to kind of daydream
Yeah.
with technology?
Yeah. That's exactly what I was getting at. Because I think amongst engineers and STEM people in general, there's almost I don't know, a lot of them have like a sort of disdain for art. Like, oh, we're engineers, like. But it seems like a lot of your work and the incredible things you're doing with digital fabrication and stuff like that is coming from that mindset of being able to iterate quickly, prototype quickly.
Yeah, I guess like there's often this idea of like disciplinary boundaries that, in my opinion, often just like makes things complicated
Yeah.
because I think you need different expertise to address different types of problems, be they like specific design problems or specific
Mm-hmm.
constraints that you're going to have to deal with. And like being able to sort of actively assemble teams with the expertise that you need to work in the space that you have identified. Sometimes like sometimes quite limited by certain attitudes that come from certain disciplines.
Yeah.
Like as an example, I was just on a program committee for a conference, an interdisciplinary conference about digital fabrication. And one of my colleagues, in reviewing another one of our colleagues' work, said, well, this paper doesn't have a formula in it. Therefore, should we accept it? And that, I think, that kind of attitude can only make our work worse.
Yeah. Yeah, I think that's actually sort of what I was going to get into a little bit going forward, is that your sort of specialization is in itself pretty broad. Like you define your work as saying, I make machines that make things. And did you face kind of resistance in pursuing that kind of path because of this pressure that you need to specialize and be an expert on one specific thing and fall into that disciplinary boundary?
Well, yes, but to go into more detail on that, I guess what I see as one of my greatest strengths as a designer and as an engineer is one of system integration. You know, you could have like a perfect wireless communication protocol. If it doesn't talk to any applications, then doesn't matter.
Yeah.
And so I think that thinking about bigger systems and system integration requires you to have a lot of low-level expertise of different systems that you want to work together, but also you have to maintain a high-level overview of what is it that you're actually trying to achieve? Who are you trying to build this for? Like, what do they need? Because you could build a solution that is perfect for someone who doesn't exist.
Right. So I guess yeah, but I think it is still kind of interesting that, navigating sort of the broadness and specificity in research. I remember when we were corresponding by email a little while ago, we were talking about like research questions, right? And to emphasize on like methods and questions as opposed to being in like I don't know, a sort of declarative like mission statement, as you put it, or in a field that way. So
yeah, I mean, I think a lot of ways that I think about my work, like the way that I can sort of structure what I'm doing and who else is doing stuff like me, comes from science and technology studies, which is a field in the humanities where they look at what scientists and technologists are doing and why are they doing things, how are they achieving them, who is involved, and how. And so, for me, thinking about my own practice, I feel like I sometimes have a much broader understanding of the methodologies and epistemologies that others operate from. And that, I think, is something that is really valuable for everyone to have, especially if you want to engage in interdisciplinary work. I think, just to give another example of how that doesn't work, is when people say, well, everything is just the scientific method. Like everything is just the scientific method. You have a hypothesis and then you do an experiment and then you prove or disprove the hypothesis. That's not the method really that's used for a lot of things that happen in engineering and design.
right.
Twitter as a project was originally an academic project, is not something that is a hypothesis that's being proven or disproven. An MRI is not a hypothesis that is being proven or disproven. Maybe there are questions like within the development of those kinds of systems that are hypotheses that are proven or disproven, but broadly, it's not like we think
everything
the
fits
world
into
is
that
round. Like we're going to do this experiment to figure out,
Yeah. That's cool. In a way, sort of, your broadness and understanding of that epistemology, like you said, becomes your specialization or becomes your strength. And in that way, you're able to work on all these different types of things. That's really cool to me because, like, from a student's perspective, being, kind of young and being interested in all these different types of things, they're always telling us, you got to specialize, you got to go into this one thing, fit in your little box, you're an electrical engineer. But it's just encouraging for someone like me to see that there actually is a lot of strength in being able to look at these different fields and operate from that perspective.
I mean, I think it's in when you're a student, part of what you're learning is how to think, how to learn. But then more specifically, I think this is maybe what other people who've been giving you advice in the past mean, is experiencing like these kinds of problem solving scenarios is really where a lot of the learning happens. So you really do, I would concur that you do need to go deep into different things to be able to understand what they really are when the rubber hits the road, like what is going on. And if more people did that, then conversations would be really different. Right now you have a lot of conversations about AI.
Yeah.
And, that makes sense because not everyone wants to participate in the practice of AI.
Yeah.
But still, that as a student, what you want to be able to think about is what are the concrete limitations of this methodology? What are the big questions that we're asking next? What will happen once we're able to achieve X, Y, and Z? And so as students, going deep and really being there where the rubber hits the road, I think is where a lot of learning happens.
That makes a lot of sense. To shift gears a little bit about your own work, what's the vision with digital fabrication in general? What keeps you motivated to keep after it?
Well, I would say my work has previously been specifically about digital fabrication, computer controlled processes, specifically for making things. But actually now I'm a little bit more broadly focused on automation in general. And so not just automation for manufacturing and fabrication, but also automation for tasks like laboratory automation in scientific experiments, or automation for things that don't necessarily have physical outputs, but maybe have data as output, for example. And I think of computer-controlled processes as having a major benefit, which is that they are repeatable and they're precise, but that they also have major drawbacks. Right now, they're really hard to build. It's not necessarily that accessible for non-experts to be able to take advantage of automation. And so there I'm interested in what does it take for this really to be something that can be used as just another tool?
Yeah.
What I think of as the future of automation is pretty different from what I think is the present of automation. I think right now automation is used by entities that have expertise, that are large, that maybe have mass manufacturing or high throughput at their core.
Yeah.
And it's not so much used by, just people who are exploring, people who are interested in something that maybe isn't going to have 1 million runs, but maybe would have 100. And so I think what I think is that if you have more modular and accessible tools for automation, that you can have more diversity of practice. And so that's the kind of the future that I am envisioning, and the contributions that I am making.
This sort of thought experiment, I guess, where I thought, right now the world's population, the number of engineers we have in the world compared to the world's population is pretty small. And I wondered, what would the world be like if, for example, a majority of the population had access to engineering skills and tools, and let's say, just in the extreme case, everybody was trained as an engineer. And And I was just imagining like, okay, in that kind of case, like what would we create? Like how fast would we be able to deal with and solve all these problems that we're currently struggling with? And it was
Yeah.
a pretty interesting thought to me.
Yeah, absolutely. I mean, I think that like for me, those things, that question of like what happens if we had more expertise, it kind of can be answered, or you can kind of address that from two separate directions. One of them is the one that you point out, which is like, what if everyone had this education? What if everyone knew how to do this kind of stuff and learned the same stuff that you've learned in your training? But then the other one, which I think is also interesting, is what if we changed technology or made novel technology that made it such that you don't actually need all of that like the all of the education that you currently need to be able to enact that kind of thing.
Right.
Are you familiar with the Arduino platform?
Yeah.
So when I was an undergrad, there was no Arduino yet.
Oh, okay. Yeah.
And one of the things that I spent time with microcontroller programming and learned a lot and programmed things like picks and with languages like just another language, JAL. And it, there was like there were a lot of barriers to doing work with microcontrollers, and senior students whose work I admired would write whole dissertations about projects like being able to do new kinds of interactions or new kinds of interfaces, and they would develop new systems to be able to make those projects, and it would take them years. And now many of those projects, I think, could easily really be produced by undergraduates who can use Arduino,
Right.
And so to some extent, it's like, what if everyone had the same training as those senior students that I knew when I was an undergrad? Or what happens if we have more systems like Arduino? I think Arduino is not necessarily taken seriously by a lot of electrical engineers because it's a very simple platform.
Yeah.
But at the same time, it completely changes who participates in designing and making circuits.
Yeah.
Which I think is awesome.
Yeah. And I think your version of it is maybe a little bit more practical and a little bit more exciting because, like, there's definitely two angles to it, and I think that the other angle is like definitely a very exciting one.
Well, I think both are important. I think both are important. I think that access to education is like of paramount importance.
Yeah.
And then I also think that when we develop technology, we should think about like what is the future that we're trying to enact with this technology. And I definitely know some like older professors who will always say like, well, I learned microcontroller programming in assembly with the 8051 architecture, and that's the way everyone should learn it because that's how you get a good basis. And there is something to be said about that, but I think that if you want broadening of participation, maybe not just that as an educational approach, but also more would be good.
Right. And I think the educational approach is somewhat being solved with kind of the internet and online learning like we're doing right now, and like recent developments with that. It's becoming a lot more accessible. But I think one of the problems with the other side of it, especially when it comes to like manufacturing, is that if you have an idea, it's still pretty expensive to manufacture something. Like if you want to do something fabricated to justify the cost of it, you have to be producing like a very large number of units. It still has to be really high volume, right?
Totally. But I think that is also changing. I think that's actually pretty rapidly changing. I think, before when I was an undergrad, there was barely eBay. I mean, eBay existed, but it wasn't like you could just go and buy a bunch of stepper motors or like slip rings or other like the barrier to production is lower. It's still not so low that everyone is doing it all the time. But it's definitely lower. And I think that's pretty exciting. And I'm interested in like, what can we do to further lower that? And
I
I
think we
guess
have
that,
like pretty good
sorry.
prototyping tools, right? But if you want to make something, I don't know, kind of to take it to the next step, don't you still have to kind of, get it to a factory and, go through that entire process?
Well, I think that kind of depends, right? Like, so say you design something that can be 3D printed out of a single material.
Yeah.
Like, to some extent, maybe what you want to do is then lower the cost. You think you're going to sell 1 million of them. So instead of 3D printing them each time, you make a mold and you have them injection molded, and then they're like pennies on the dollar for each unit. Or maybe you think, well, I'm not going to sell millions of these, so the cost of a mold is maybe not worth it. But instead, everyone can just order this from a 3D print on demand service, like Shapeways, for example.
Hmm.
And something like Shapeways then is the factory, the way that
Yeah.
what you would think of as the factory. And that's a pretty different model. And I think that there's a very limited number of products that maybe could be 3D printed out of one material and shipped directly from Shapeways.
Hmm.
But it's non-zero, and I think more products like that and more processes and services like that are increasingly coming into existence.
Yeah. Like the sort of way I think about this sometimes is kind of like the personal computer. Like at one time, if you wanted to get something computed, you wanted to maybe simulate something or something of that nature, they had these like I don't know really old timey big computers that I don't know too much about, but now like you can anybody can buy a laptop and laptops are pretty powerful and it's just like that totally changed the game. So what would
Totally.
you say? Do you think that something like the laptop or the personal computer, something like that's possible um, in this kind of digital manufacturing kind of realm?
I mean, I think that you have to think carefully about what is happening. So, like the first computer, the first computers were developed with like specific tasks, and a lot of those tasks had to do with the military.
Yeah.
And when they became personal computers, the the applications that were the applications that were being used on personal computers were quite different, like early word processing, early image manipulation, early spreadsheets.
Hmm.
Um, and so, if you think of the analogy between industrial fabrication and personal fabrication, I think you have to think about what is not necessarily the infrastructure, like the thing that is fabricating, but what is the application that is being addressed. And word processing and image manipulation has been shown to be really popular for individuals. But for fabrication, is it, I guess the thing that people often have in their mind is sort of this like sci-fi, like these images from sci-fi, like the Star Trek replicator, and you walk up to
Yeah.
it and it gives you whatever food you want, for example.
Yeah.
Um, and I don't know that application, well, maybe having a food making thing is really useful. And if it were good at it, then people would want that. But for like the other objects that you have in your, like right now, I'm sitting at a desk, I'm sitting on a chair, I have a microphone, I have a computer.
Hmm.
Those are like things I'm using every day, all the time. Like, are those things that I'm going to start fabricating myself? And is everyone like me going to start fabricating those themselves? I'm not sure. And so, what are the things that people like want that level? What are the things, the applications that people want that kind of agency over? And before thinking about personal fabrication the way that we think about personal computing, I think we have to think about like what are these things that people want and who wants them.
Right.
And so before going all the way to like, okay, me at home making things for me to use at home, maybe first it's like you know, people who are interested in design or interested in engineering manufacturing, how do you make it easier for them to produce things in low volume? So rather than saying like, okay, everything needs to be made in a factory, the thing you were sketching before, this sort of scenario,
Yeah.
rather than that, what does it look like for something to be like, what does it look like for something that's more complicated than a single plastic object to be fabricated with like different services? How can that work? How do things like quality control work? How does system integration work for that kind of task? And so I think before we get to personal, maybe we have just like community or smaller groups. Like I'm part of a community of people interested in plant biology, and I want to create like different platforms for me to be able to grow different plants and measure different kinds of outcomes from those plants.
Right.
Or like an example, like your example, the thing that you made where you're moving you were like measuring an electric field. Can you explain that one again?
Oh yeah, sure. I repurposed the CNC machine to like scan different points or measure different points of the magnetic field of a wireless power coil, just in like a 3D space because it can move along those three axes.
Yeah, exactly. So you have like a task that you wanted to do, and to do it, you needed a machine. And so then you built a machine by repurposing another machine, and and you managed, and it was cool. But what if like it were even easier and more people could do that kind of machine design and machine building? That I think is maybe like what I see as happening first before you have the thing. I don't know. I feel like the thing that a lot of people talk about is like, what if your grandmother could 3D print her own cups? Like, I just don't know that that's going to be the first application that's really popular.
Yeah, I think you're right. Maybe like, do people even want that badly right now? Like, I don't know. I think maybe the more relevant thing is for the engineering community. Like, for example, if you want to do a hardware startup, it requires like a ton of money to get anything done. You need
Yep.
like a really big investment and everything like that. So I think bringing those numbers down, bringing those costs down is probably like a bigger concern and would be, I think, pretty exciting.
Yeah, absolutely. That is also what I think.
Mhm.
Um, I think there's lots of places. There's lots of places where that work like takes place. I think that it happens in better design tools and novel design tools. It happens in machine design and like different machines that can produce different things, different kinds of services, different ways of scaffolding community. Like there's so much work left to be done, but luckily it's all pretty cool.
Yeah. So to talk a little bit about your own background in this type of field, was this that type of thing that you were always interested in, or did it develop more at your time at MIT with the Center of Bits and Atoms? How did that play out?
Well, so I'm from the Netherlands, and I went to undergrad in the Netherlands, which is a cool place. And I started in art school. I've always been quite interested in making things and like enjoyed making things.
Hmm.
And I transferred at some point from art school to artificial intelligence, or I ended up majoring in artificial intelligence at the University of Amsterdam instead of staying in art school because I was interested in making things with robotics effectively. Or like I was interested in
Hmm.
computational systems and robots, and taking classes in artificial intelligence, which by the way at the time was a lot less popular than it is now, was like a way for me to learn things like embedded programming and things like expert systems. Like there's a lot of skills that I thought I could use for making things that I could get from switching majors. And then once I went to MIT, so then I went to MIT for graduate school. And actually, maybe the story of how I did that is funny, which is I also worked at an art institute in Mediamatic, which is an awesome art institute in Amsterdam, which still exists now. And they have great vegan pizza that you can eat in socially distanced little glass houses on the waterfront. So everyone should go there. But Mediamatic is an art institute where they let me do all kinds of crazy things, like run. When I was sort of towards the end of undergrad, Arduino actually just came out, and I invited the founders to come teach workshops, or they let me like buy embroidery machines and hack RFID tags and other stuff like that. And one of the things that we got up to was running an exhibition about a series of typefaces, Arabic typefaces that were developed with Dutch type designers in collaboration with Arabic graphic designers. And as part of this exhibition, we made like a parody of a Dutch department store called Hema. We made an Arabic parody of it called El Hema. And then the Dutch department store has a strong visual identity that uses a lot of typography. And so instead of having them be in the Roman alphabet, we made a lot of products that had Arabic on it. And the way that we made them was using digital fabrication. Arabic has a lot of like ligatures and other complexities, a lot of curves. And I was trying to use this software from MIT at the time to be able to program the machines to be able to cut out the stickers with Arabic, or cut out the molds that we're going to use for making Arabic chocolate letters. And, this software was just like bad at it. It was bad at curves. It was from the Center for Bits and Atoms, and I thought it would be great because, MIT is supposed to be really great.
Yeah.
And it just like didn't work at all. So then when Neil Gershenfeld, who was sort of the founder of the Center for Bits and Atoms, and by the way, the department store was like vastly popular. It was like very, very, very popular. So it constantly was selling out. So we constantly had to make more stuff to sell in it, which is the most we could have like hoped for. If you're like doing an exhibition about letters, often only a very select group gets interested. But because of how Mediamatic and the exhibition was like so positioned, it became like really famous and really popular. And so Neil Gershenfeld, professor from MIT, came to see it, and I had the opportunity to say, this digital fabrication software that you're developing is really not very good. And I'm like, here are all of like the situations in which this doesn't work. We're not trying to make lots of multiples, so I need to be able to reprogram constantly, and it takes a really long time for me to calculate these tool paths. Like my computer freezes up for literally 45 minutes every time I want to calculate a new curve, but I have hundreds of products I'm trying to ship, so this is really unacceptable, yada, yada, yada. And Neil was like, have you considered graduate school? And Neil, maybe was also Josh Smith's advisor.
Yeah, no, I've read some of his stuff. He's really cool. I was like, I don't know. I would really hope to be able to talk to him one day, maybe do something like this, but I don't know if he'd be open to it. But yeah.
Well, he's quite busy.
Yeah, I know. I figured he'd be really busy, but I've been following his stuff for a little while. It's pretty cool.
Yeah, and I think that, the reason that we had the tools that we had for making these products in El Hema, our department store, was because of the popularization of digital fabrication through places like Fab Labs, as advocated for by people like Neil. And so there was definitely like a strong connection there. But that opportunity of being able to make things, at least for me, quickly reached like a technical boundary where I was like, there's things I need to do. There are things that are conceptually not difficult for me to conceive of how they should get done. And this doesn't, but these systems don't exist yet. Mm-hmm. And so that's, I think, like really that was really for me a moment where I was like, this needs this needs to be better. This needs to be different. This needs to be open to more people for different kinds of experimentation. And and that's how and that's really how I think I got initially involved in it, from a strong background of making things, from like a lot of stubbornness in like believing that I should be able to get technical systems to work. With like a strong desire to like see these kinds of projects through.
That's a really cool story. So I see this again and again, that following your own kind of curiosity and creativity has the best, I don't know, it does good things for people, I think, and more people should do it.
Yeah, I mean, I don't know. I don't like following your own creativity. I feel like a lot of the time these kinds of stories are the ones where you can like, after they were successful, you like justify why you were doing them. And then you're like, oh yeah, I was just following my curiosity. And then I happened to like become a professor.
But there's like wouldn't you say there's like a weird number of stories like that though, among people who, I don't know. Like,
yeah, but I think at the same time, that's also like the story that people like. Like, this is definitely a story I like to tell about myself. But I would also like to stress that there are plenty of stories where I just like did a bunch of stuff for a long time that didn't work. And like, I didn't publish it. It didn't become a successful parody of a department store. It didn't, and I don't know. I don't want to give the impression that everything I did or am doing is like destined to be successful. I think a lot of it is like noodling around and figuring stuff out. And that sometimes like teaches me stuff. And sometimes I get to build things that are useful to other people. But a lot of the times that's not the case. And that's still okay.
Yeah. What do you think is the best idea you've had?
Best idea I've had?
Whether successful or not.
I feel like for me, I think of everything as sort of like complicated and intertwined. So everything is like all part of lots of bigger things. And I guess like one thought I was pretty young. I was like 7 years old and I was skiing. And my dad was supposed to pick me up from where I was on the bunny slopes. And he was late because he was always late. And he didn't pick me up. So then I thought maybe I should like try to go home by myself.
Yeah.
And then I started skiing down the mountain, which was way too big for me. And like, I couldn't do it. I was like, it was too difficult. And I was like, okay, I can't do this. I need to do something else. I won't make it down. And so I took off my skis and I started climbing back up the mountain, which is, I was young, skis are heavy, ski boots are uncomfortable. And I was walking up the mountain and I was thinking like, this sucks. Like, why doesn't my dad ever pick me up? And then I thought of it. I was like, okay, well, there is a distance between me and the top of the mountain where I can try to get on the gondola and go home that way. And if I continue, I am going at a speed. And so in going this speed, I will eventually cover this distance. And so the amount of time between now and when I have solved this problem I'm currently facing is finite. And all I have to do is keep going. And that I think really, really informs me in a lot of situations now, where I'm like, okay, I see where I'm going. I don't know exactly how I'm going to get there, but I know that if I keep going, I will get there eventually. And that's just going to be how it is. Yeah.
Cool. That's not where I was expecting the story to go, but that's pretty cool. Like I thought there was going to be some like, moment of ingenuity or something, but so I think actually that maybe that is a moment of ingenuity, right? I think just being able to think that way about stuff.
Yeah. Or like acknowledging that you don't know how much work is ahead of you, but you know that if you keep going, you will get it done.
Yeah. So I think we're kind of running out of time, so I want to ask one more thing. With regards to your work, do you worry that you're going to take jobs away from people if we have too much automation? People are going to, the economy, people are going to lose jobs, stuff like that.
I worry about a version of that. So yeah, I think that like automation right now, there's a lot of work that's being performed that is being automated away. Like that if you could buy an automation system, maybe you wouldn't employ people to do that work.
Yeah.
And I think of that as like there's like several problems there. One of them is that there isn't enough work for people of a particular skill set. And so, there's a big swath of people who struggle finding work that's well compensated and like allows for human well-being and flourishing.
Mm-hmm.
And I think that that's a separate problem. I think that like lack of work and lack of kind of like human flourishing and the dignity of self-sufficiency, that's a separate question from getting rid of certain jobs. A lot of the jobs that are being automated, I don't think are particularly good jobs. I don't think that they enhance dignity or human flourishing.
Mm-hmm.
And so there, I think that, the thing we were talking about before, which is on one hand, like educating people to be able to build systems, and on the other hand, building systems so that you don't need a lot of specialized training to be able to perform this kind of creative and problem solving work. But that's kind of where I think of like a really important thing happening next. So rather than saying like, oh no, we shouldn't automate fabrication and manufacturing because then all these fabrication and manufacturing jobs are gonna disappear.
Yeah.
I think what we need to think about is what is the future of manufacturing and how do we train a workforce that can engage there? There's so much expertise in fabrication. There's so much expertise in production. There's so much expertise in things like laboratory work. And how do you upskill? How do you create systems that allow for people to do the same type of work that they were doing before, but in a more powerful way? How do you create new types of technology that allow people who were previously not able to work in, jobs like manufacturing or jobs like laboratory work, and create systems such that they can participate in that kind of labor, and that it's labor that takes advantage of their inherent human creativity and problem-solving capabilities, rather than, just thinking of them as this like source of
Like
unskilled labor.
Yeah. Yeah. I think, I heard one Silicon Valley investor slash personality, his name is Naval. He talked about kind of like where the economy might be going, or he was talking about this idea that wealth and human flourishing is not zero sum, and that if the economy was based on everybody, for example, being able to work based on their creativity, use their creativity, then that is kind of the direction things are heading, and that you already see this kind of happening with content creators starting to be able to make money off of their own creativity in ways due to some of these tools that are coming out, like, for example, video and video editing tools. A lot of people to become YouTubers, stuff like that.
Yeah.
But I don't know, something I'm curious about is, do you think that you could teach creativity?
Yes, I absolutely do. I mean, I think, what I think is sort of a damaging, I think there's like a lot of damaging narratives that it's like this thing where an apple hits you on the head and you have a eureka moment and you like solve everything.
Yeah.
And that, I don't know, I once read something about Picasso, the painter, that he woke up every day and got to work by 5 a.m. and worked. And if he didn't paint, he like made new canvases. And if he didn't make new canvases, he like cleaned. And if he didn't clean, he did. So it was always just actually showing up and doing work. And I think that that's also how creativity happens. You have to like show up and have strategies for like figuring out what to do if you get stuck, and like trying different options and structuring the ways you try different things. And that creativity, I think, benefits all fields, like engineering, making music, doing different kinds of design. Like that's it's like showing up and putting in your effort. I guess for me, I think a big part of what's important is to think about ourselves as part of society, and part of a culture, and a culture that is enacted through different practices, and that the practices that you perform sort of shape what is our society and what is our culture, and that can't just come from one kind of way of looking at the problem. You can't come from just thinking about how do we make more money. It can't just come from thinking about how do we make things more efficient.
Right.
It comes from a much richer place than that. And that's, I think, the representation that I think needs to be reflected in like the design of systems. So that's what I try to do anyway.
Yeah, I totally agree. I think that's really powerful. I think probably the most, I took a class at UW last year. It was called Creativity and Innovation. That was the title of the class. It was a 2-credit seminar type class taught by like an old professor who was kind of retired in the chemical engineering department. And I think that did more for me than almost any other class I took. Just because it just because of the idea that, hey, you can think about things in a different way. It's not always about, like you said, in pursuit of that specific type of goal, reducing costs, efficiency, stuff like that. And it actually is a very powerful thing. Like just to believe that you can, and just to allow yourself to be creative in a way.
Yeah.
Yeah, it's really cool. All right, I think that was a really interesting, great conversation. I really appreciate it. Thank you so much for being here. Thank you.
Totally.
Yeah, it was really fun.
I love podcasts. So
Yeah, I'll stop recording now because I think.
Okay, bye, listeners.
Yeah. See you, everybody. Thanks for listening in.